Hello and welcome, ladies and gentlemen. We are back in topic 2, packet 1. We're going to be doing activity 1.3 here, talking about inscribed angles, arcs, and tangents. First thing, we're going to be looking at this diagram for most of the video. I will keep kind of bringing it back and forth, putting it up on the screen as we need. We'll go ahead and hop in. Number 1 says, consider Don's completed diagram. Identify 2 inscribed angles in the diagram. So if you aren't sure what an inscribed angle is, you can watch the vocab video if you want. That's 20 minutes, or you can just look at this right here, okay? An inscribed angle is an angle whose vertex is on the circle. I'm going to underline that. Whose vertex is on a circle, and whose sides contain chords of the circle, and whose sides contain chords, okay? So if you'll look, here's an example. The vertex, or the point of the angle, is on a circle. It's right here. It's on it. And then both sides are chords, which are lines, or line segments that have 2 endpoints on the circle. So here's 1 endpoint, 2 endpoints. That makes this side a chord, and then 1 endpoint, 2 endpoints on the circle. That also makes this a chord. Okay, so I'm looking for 2 angles like that are on this diagram. I would go ahead and just start with the points that are on the circle and see if they have 2 points that come away from them, because like here, if I have a point on the circle and it has 2 lines that go away from it, it has a possibility of being an inscribed angle. So I'd start with B, and I see there's only 1 line going away from it, so I'm going to go ahead and just work clockwise here. I'm going to look at D, only has 1 line going away from it, can't be an inscribed angle. Look at E, only 1 line. Look at P. P has 2 lines going from it, so it can be an inscribed angle. Now I just need to check to see if these lines are chords. So P is an endpoint on the circle. If I go over here, M is also an endpoint on the circle, so there's one side that's a chord. If I look, P is still an endpoint on a circle, and if I go down to O, that's not an endpoint that is on the circle, but if I go all the way down to B, that is an endpoint that's on a circle. So I could say that angle MPB, okay, is one of them. So that's one inscribed angle, and you can kind of see how that's similar to this one, okay? And then now, that was point P. Now going over to M, it looks like M has 2 lines that come away from it as well, so it also looks like it could be an inscribed angle. So I just need to check to see if these lines are chords. I already know that MP is a chord from my last one, so we know that that's a chord. And then if I go from M to O, those both aren't endpoints that are on a circle, but if I go all the way over to D, that makes MD a chord, so I can go ahead and say that angle PMD is also an inscribed angle. And there are only 2 in this diagram, so it says identify 2. If you get a different one, just double check to make sure that you have your vertex on the circle and that both sides are chords. Okay. So now we have this lovely paragraph here. Basically, it's telling us what an intercepted arc is. Okay, I'll go ahead and read it. The vertex of angle PMD, so that one that I just was talking about, the vertex is on the circle. The 2 rays of the angle intersect. The 2 rays of the angle intersect the circle at points P and D. So the 2 rays intersect at points P and D. This makes arc PD an intercepted arc of angle PMD. An intercepted arc is a part of the circle that lies in the interior of an angle whose endpoints are with endpoints that are the intersection of the sides of the angle and the circle. Basically saying, okay, here's an example over here, back on our inscribed angle. If it would be what's contained within these 2 rays here. Okay, so what's inside here? So this example, what I've just kind of darkened a little bit or highlighted, okay, that would be an intercepted arc. And so what it's saying is that for angle PMD, this one that we marked as a inscribed angle, that its intercepted arc would be PD. So from here to here. Again, that's because the ray that's created by these 2 lines, okay, what's inside that would be PD. So that's an intercepted arc. So question 2 says central angle POD also intercepts PD. Compare the measures of POD, angle POD, and angle PMD. What do you notice? So I'm looking at these 2 angles. I'm looking at angle POD. I'm looking at angle PMD. Okay, if you remember from the last couple activities, if you've seen those videos, or if you just remember from doing it on your own, the angle of this measure, or the measure of this angle, excuse me, the measure of this angle is 45 degrees. And then we know that MD, this line MD, and line PB are perpendicular bisectors, which means that all of the angles created by these 2 lines are 90 degrees. Okay, so that means that POD is a 90-degree angle, and PMD is a 45-degree angle. So there's a couple things that you can notice about these angles and how they're related. What they're trying to get you to see, though, is that how this 90-degree and how this 45-degree are related. So 90 is twice as much as 45. 45 is half as much as 90. So what we're looking for here is that if I have, so if I have a central angle and an inscribed angle that have or that share an intercepted arc, right? Because both of these intercept the arc PD. PMD, we talked about that right here, and then we also said that central angle POD also intercepts PD. So if I have a central angle and an inscribed angle that share an intercepted arc, the measure of the inscribed angle is half the measure of the central angle. I know that's a lot of words. Okay, that's just saying if I have central angle and an inscribed angle that both intercept the same arc, which I do here, the central angle is going to have some angle measure. In this case, it's 90. The inscribed angle is going to have whatever, it's going to have half of whatever the central angle's measure is, in this case being 45. And that's going to be an assumption that we make, okay? So what do you notice? That's just something that we notice. This is kind of formal, but if you just notice that, you could just say PMD is half of POD. You don't have to get quite this formal if you don't like. That is just what they are trying to get you to see here. So now going on to number 3, okay, talking about Vicky. Vicky conjectured that the measure of an inscribed angle is equal to the measure of a central angle when both angles intercept the same arc. Do you agree or disagree with Vicky's conjecture? Draw examples to justify your answer, okay? So I'm just going to go ahead and freehand this here. Okay, I have a circle. I have a central angle. Right? Here's a central angle. Remember, a central angle is an angle whose vertex lies in the center of the circle. And then I have an inscribed angle, and you can put this inscribed angle anywhere as long as it intercepts the same arc, because that was one of the things, intercept the same arc. So as long as I have a point that is on the circle and intercepts these 2 points, that would be a good inscribed angle for us to use. I'm going to go ahead and use this one. I think that it's easiest for people to see when I put it right here, that these 2 angles, or to see how these 2 angles are related, I should say. Okay, so it says, do you agree or disagree with Vicky's conjecture? Well, she's saying that the central angle and this inscribed angle have the same measure, okay? And I freehanded this, but I tried to freehand this as best as possible to be a 90-degree angle, okay? And we can see by looking at our inscribed angle that this is definitely less than 90, right? We know that this is not a right angle, so we would go ahead and say, do we agree or disagree? We would say that we disagree. And then draw examples to justify your answer. Well, here's an example of a central angle that measures 90. And if you wanted to construct this to make it exactly 90 degrees, you are more than welcome to do that. Again, I'm freehanding here. And then if I make an inscribed angle that intercepts that same arc, and you can see if I put the inscribed angle elsewhere, so let's say I put the inscribed angle directly below this point, okay? And then I intercept those, so now my inscribed angle goes like this, right? We can see that that is still less than 90. You can put it over here. You can put it wherever you like, okay? What you should hopefully see is that all of these inscribed angles are, in fact, smaller than that 90-degree angle, right? And so these could be your examples that you reference. I would hope that you would write more than disagree in this part, and then maybe talk about these examples, or draw multiple examples and point to those, okay, do some arrows, stuff like that. You'd be good to go there. So now we're looking at number 4. Consider the measures of inscribed angles that intercept the same arc. What conjecture can you make about this relationship? Use examples to explain your reasoning, okay? So basically what I'm going to do, I'm just going to start by drawing an intercepted arc. First thing I'm going to do, intercepted arc, by drawing an inscribed angle, and I guess also an intercepted arc, because inscribed angles create intercepted arcs. Anyway, here we go. So the measure of inscribed angles that intercept the same arc. So here's one, this is just an inscribed angle, nothing special about it. Now I'm going to create another inscribed angle that intercepts the same arc as the one I just made. So now I have 2 inscribed angles that intercept the same arc. I can go ahead and make a third one if I want. I could keep going, make a 4th, a 5th, a 6th. I could do as many as I wanted. Hopefully you can see here, again, I'm just freehanding this, but hopefully you can see that these all look like they have about the same angle measure. And I'll go ahead and do a 4th one just for fun. Okay, we can see that these look like they have about all the same angle measure. So what conjecture can you make about this relationship? Use examples to explain your reasoning. So what conjecture can we make? That all of the inscribed angles have the same angle, have the same angle measure. Perfect. Okay, so that's our conjecture. So what conjecture can you make? This would be it. That all of the inscribed angles have the same angle measure. Again, inscribed angles that share an intercepted arc, okay, or that intercept the same arc. And then it says use examples to explain your reasoning. You could go ahead and use this drawing as your example. If you wanted to get out your protractor and measure all of these after constructing them with a compass and a straight edge, you're more than welcome to do that. Again, we are just conjecturing, we're assuming. So I'm going to go ahead and just freehand this and kind of assume that these are the same, because even when you're constructing them, we're not looking for an exact answer. We're not trying to prove anything. We're just making a conjecture, an assumption, okay? And remember that you can't prove something. You can't change a conjecture into a theorem with construction. You can't measure things. We're supposed to be able to prove them using definitions, and we'll kind of talk about that later. But again, we're just making an assumption here. So this example, or these examples of arcs, okay, or these examples of angles would be good enough for what I am asking of you. Okay, so now we're going to move on to number 5 here, okay? Number 5, we have another person making another claim, another conjecture, okay? A meet measured each of the inscribed angles that intercept a semicircle. He conjectured that the measure of any inscribed angle that intercepts a semicircle arc is equal to 90 degrees. Do you agree or disagree with this conjecture? Draw examples to justify your answer. So we're dealing with circles on all of these, so I'm going to go ahead and draw a circle to start. Okay, so it says a meet measured each of the inscribed angles that intercept a semicircle. He conjectured, so he assumed, that the measure of any inscribed angle that intercepts a semicircle arc is equal to 90 degrees. So he assumed that the measure of any inscribed angle, so we're talking about the measure of an inscribed angle here, is 90 degrees if it intercepts a semicircle arc. Well, what's a semicircle, first of all? Okay, that was pretty bad halfway mark, but a semicircle is half of a circle, right? Top half, bottom half. So this is a semicircle, this is a semicircle. Okay, so a semicircle arc is going to be the arc that is created when we create a semicircle, right? This bottom half, this arc from here to here, again, my freehand is kind of bad. We can use our imagination, right? This bottom half of the circle is a semicircle, and so the arc that is created by that semicircle is a semicircle arc. So he's saying that if I have an inscribed angle that intercepts a semicircle arc, okay, like this, he's saying that this measure is going to be 90 degrees. And he says that any inscribed angle, that the measure of any inscribed angle that intercepts that is going to be 90 degrees. So he would have more than one example like this, okay? Right? So we have 3 inscribed angles. He's saying that all of these are 90 degrees. So then the question is, do you agree or disagree with his conjecture? Draw examples to justify your answer. Okay. I would go ahead and say, now if we flip back to number 2 really fast, you'll remember we said that if a central angle and an inscribed angle share an intercepted arc, that the measure of the inscribed angle is half of the measure of the central angle, right? That was a conjecture that we made, an assumption that we made. So now, okay, on this one, I have a central angle here that's a diameter, and the measure of this angle, the measure of any line, any straight line, is 180 degrees. Right? And that makes sense because this is a semicircle, and a full circle has 360 degrees in measure, so this half of a circle, a semicircle, would have a measure of 180 degrees. So we said that any central angle, okay, and an inscribed angle that intercept the same arc, right, which these do, we said that the inscribed angle measure is going to be half of the central angle measure. So if this central angle measure is 180, half of that is in fact going to be 90 for all of these. We also just said on number 4, if we flip back to number 4, that all inscribed angles that intercept the same arc are going to have the same angle measure. So I know that all of these are going to have the same angle measure before I do anything, and then using what we found from number 2, or what we assumed from number 2, we can also assume that these are going to be 90 each. Okay, so, well, excuse me, we would agree here. We agree with his statement, his conjecture, and then draw examples. Here would be an example. You can elaborate this with words however you feel fit, but this would be good. You can draw some arrows, talk about that if you'd like, okay? This is kind of what I'm looking for. So now we're going to talk about, okay, Tad. So Tad drew 2 tangent lines to the circle, one through point L and one through point G, to form a circumscribed angle, angle GQL there, okay? So If you're unsure what a tangent line is, there's the vocab video. There's also this description over here. A tangent to a circle is a line that intersects a circle in exactly one point, called the point of tangency. So you can see here's an example of a tangent line. It intersects the circle at point Q, and that's the only point that it touches the circle. Then over here in this diagram, it said that Tad drew two of them that intercept at point L and point G, and we can see that these lines, they touch L in one spot, they touch G, they touch the circle in one spot, in L here, and then G there, okay? And then so if I have two tangent lines that intersect each other, which I do here, okay, so tangent line 1, tangent line 2, right? If I have two tangent lines that intersect each other, if I put a point there and then measure that angle, that is called a circumscribed angle. And then there's also the definition of that down here. So it has two sides tangent to the circle, which is exactly what we have here in our diagram. So number 6 says, what conjecture can you make about the measure of angles formed by tangent lines and the radii of the circle? If you remember from, I believe it was the activity 1.1 video, we talked about radii. That just means that there is more than one radius, okay? And it says draw examples to explain your reasoning. So this one, I'm going to kind of cheat a little bit. The answer is hidden on this paper, and they actually have marked it for you multiple times. So it says, what conjecture can you make about the measure of angles formed by tangent lines, so formed by a tangent line, and the radii or radius of a circle? So here's a tangent line. Here's the radius of a circle. Here's a tangent line. If I wanted to connect it here, I could use my straight edge to be official. I apologize about the shadow here, about the lighting, okay? So if I use a straight edge to connect that, I want to know what this angle measure is and this angle measure is. That's what we're talking about, formed by a tangent line and a radius. It says draw examples to explain your reasoning. So they actually have put the answer on here in 4 different places, if you look closely, okay? So one of the places right here, okay? So I have a radius and I have a tangent line and I have this little box marker for the angle, which of course means 90 degrees. We've learned that. We've talked about that a bunch of times. Also, in the definition of our tangent line, we have another box that tells us it's 90 degrees, again, because this is a radius from the center of the circle to the edge of a circle, right? This is a line segment, starts in the center, ends on the circle. And so we have another 90 degree marker here. And then even on our circumscribed angle, we have 2 more radii and we have 2 more box markers. So on this one, they actually have the answer kind of hidden on here 4 different times. And I wouldn't even say it's hidden, right? It's there 4 times. It's kind of looking at you right in the face. So we're going to go ahead and say, what conjecture can you make? We can conjecture, or we can assume that all of these angle measures are 90 degrees, okay? And again, all of these angle measures being angles that are created with tangent lines and a radius of a circle, okay? All of those are always going to be 90 degrees, and that is something that we will prove later, but for now we're just assuming that, okay? And we don't have to worry about that. So now, is there more of 1.3? Looks like there's not. So the next video, okay, we just finished activity 1.3. We'll be looking at the talk. We will walk through all of those. We'll walk the walk through the talk. There you go. So we will go ahead and work through this table on the next video. I hope you all have a wonderful evening. I will see you later. Adios.